Hey guys, so today's lesson is going to be on factoring polynomials. And before we get started, I just want to really make sure that we're understanding the difference between factoring and solving. So this is something I see a lot of students in Math 3 kind of mix up. If a question asks you to factor, there's usually not going to be an equal sign. They might have factor x squared minus 4x plus 3. And so your answer should look like this: x minus 3 and x minus 1. That's the answer. Okay, there are no like x equals in it because it's just factoring. This is the factored form. Okay, if instead it asks you to solve, then you're most likely going to see an equal sign. Or they might say find the roots, find the solutions, things like that. So we might have that same starting point, x squared minus 4x plus 3. But this time there's going to be an equals 0 part. Okay, and a lot of you guys will do something with the x method. Again, I said yesterday, I'm really bad at the x method. I think it goes 3 and negative 4, but it could be backwards. I honestly don't know. And then we would have negative 3 and negative 1. And a lot of students will just jump to x equals 3 and x equals 1. The reason I don't want you to do that is because you're kind of missing a step that could be important for a lot of what we analyze and what we think about in calculus. So what I would like you to do is still kind of write this factored, x minus 3 and x minus 1. We're changing the left side to that, and the right side still equals to 0. And now if you want to jump straight to the answer, you can. But really the reason this is the answer is because what we're doing is we're analyzing, well, how would we have two terms. We have x minus 3, and we have, that's our first term, and then our second term would be x minus 1. And so these are two numbers multiplying. The first number, if x was 7, the first number would be 7 minus 3 would be 4, times 7 minus 1 is 6. 7 times 6 is 42. Well, what we're saying is, well, how would we get to numbers that would be equal to 0? Well, either this yellow part, x minus 3, x minus 3 could be equal to 0, right? Because anything multiplied by 0 is 0. So if x minus 3, if that part was 0, then the entire thing would become 0. So that's why we have x equal to 3. And x minus 1 equals to 0, x equals 1. So we have two answers. Now this is showing all of our work, all of our steps. I don't really mind if you jump straight there, but I really do want you to make sure that you include this factoring step. Okay. Don't just put the x, don't just put the x method and go straight to the answer. Make sure that you include that factoring step. But again, really going back and let's look at, hey, if a question asks us to factor, what does our answer look like? Our answer should be 2 terms factored or 3 terms factored or however many. If instead it asks us to solve or for the roots or for the solutions, then our answer should have 2x equals in it, or 1x equal, or even 3x equals. So just kind of that's clearing things up. Now, instead of me coming up with a bunch of examples, I put together kind of this just kind of steps, common steps whenever we're factoring polynomials. Okay, and we'll add some, kind of go through some examples. So the first thing before you ever do anything else on all of these problems should be to check for common terms, right? Greatest common factoring. A lot of times we can have one of these really complicated questions, kind of down at the bottom, that becomes a lot easier if we first find any common terms. So in all factoring, whether it has 2 terms, 3 terms, 4 terms, we always want to look for common terms. Right, so in this first example, 3x minus 12, we can pull out a 3 from both sides. Here, if we're looking at it, I see an x in both of them, and I see a y in both of them, so we can basically, we're dividing out an xy. There's actually a y squared. We can divide out a y squared. So when we get rid of 1x, and then the full y squared, we're left with x, and then minus 3. Right, and then these ones are a little bit different. This is definitely kind of an advanced one, but we are going to see this a couple times in calculus. So in this case, what's actually happening is we're actually able to factor out the entire x minus y term. So if we factor that out, what's left over? It's kind of like we're dividing it away. So if we divide it away, we're left with 6 plus a. Right now, we're not dividing it away, we're just factoring it to the front. But that's kind of how I like to think of that. So that's the first step always. Okay, after the first step, you're going to see these words if. If the problem is a binomial, meaning that there are two terms. If the problem is a trinomial, meaning three terms, and if the polynomial has four terms. So kind of what I like to even think of this as is you could almost think of this as like a tree is like step one is always look for greatest common factor. And then after that, kind of think, okay, how many terms, right? Are there two terms? Then we're going to have some ideas. Are there three terms? Then there are other options. Or are there four terms? So we're kind of, after we've first factored out any common terms, now let's look for how many terms are left. So if there are two terms, generally this is the only way we can factor it is if it's a difference of squares, or a sum or a difference of cubes. Okay. Notice that kind of, well, we'll get there. So the difference of squares is you have two terms that both of them can be have a square root. So maybe you have x squared minus 16, right? 16 you can take a square root, it's 4. X you can take a square root, it's x. When we say difference, that means that there's a minus sign in between them, right? So in this case, right, this is kind of like our formula, right? A plus b, a minus b. So the square root of x squared would be x. Square root of 16 is 4, so x plus 4 and x minus 4. Now, this second example is a little bit harder. And so sometimes if you get one that's harder like this, something that you guys can even do with this second example is just to kind of write out what the a and the b terms are. So the a, if I square rooted 9x squared, we would get 3x. And b, if we took the square root of 25y squared, we would get 5y. And so then with that, it makes it a lot easier to look at, oh, it's just 3x plus 5y and 3x minus 5y. Okay. And every now and then we can get a really, really complicated one. And that's if we have something like this last line. We're not going to see a lot of these unless you do the super bonus, like really challenging one. But essentially, this would be if we had a plus b squared minus 25. So we can square root this because it has the little squared in it. And so the a term would have been the a plus b, and the b term would have been plus 5, and then a plus b minus 5. And then you can just kind of combine any like terms that you have. So only if you're going to do the super challenging bonus one, there's a worksheet like that. We might get something kind of ends up being, I'm going to show it what it would look like factored first, just so we can kind of see that. Say you had like 4x plus y, right, plus 2, and then 4x plus 2y minus 2. And so if we expand this, one way that we can kind of look at this is it's just y. I like to kind of do, this is just kind of good review. We're not going to do this a lot, but when we're foiling, right, it's with two terms. When we have three terms, I like to kind of write them like how we would do when we were little kids doing multiplication. Negative 2 times 2 is negative 4. Negative 2 times y is negative 2y. Negative 2 times 4x is negative 8x. Then y times 2y is positive 2y. Y times y is y squared. I'm going to put it over here because that doesn't have a term. And y times 4x is 4xy. Right? And then we'll do it with the 4x times 2 is plus 8x. 4x times y is 4xy. I'm going to put it underneath that one. And 4x times 4x is 16x squared. We'll add a positive in front. So this ends up, these terms cancel out, and we get 16x squared plus 8xy plus y squared minus 4. So this one is a lot trickier, but that's kind of how we would expand those out. And we'll look later on about how we might factor that, but only if you're doing the really bonus challenging one. So it's just kind of like a side note, just something that I wanted to show you while we have it. A lot of times what I'm going to do in Calc is while we're learning, if there's something that I want you to know, but I'm not sure if you have known it, we'll just kind of do a sidebar like that. So anyways, we're going back to case 2. So we went over the difference of cubes. Now, difference of squares. Sum of squares really shouldn't be in here, but I just, it's a note. When we have a squared plus b squared, it doesn't factor, right? So for example, if you had x squared plus 16, that is factored. You cannot, it's not factored, but it doesn't factor anymore. It is completely factored, right? And the reason for that is if we do x plus 4 and x plus 4, and we FOIL that out, we actually get x squared plus 8x plus 16. There's this extra 8x. So basically what we're saying is x squared plus 16, basically that's the answer. It can't factor anymore. So there really is no factoring for a sum of squares. Now, for sum of cubes and difference of cubes, it's basically the same steps, okay? And so what I like to remember for cubes is this SOAP method, okay? And so what SOAP means is it means the S stands for same, the O stands for opposite, and then the AP stands for always positive. Okay? And so you might have seen this before, but if we look at the formulas here, what happens is the formulas are the ones with the A's and the B's. This is the sum of cubes, and this is the difference of cubes. And when we look at these formulas on the right side, they're almost all the same. The only thing that changed was the signs. So if we look at with positive, this is we're adding. So what the SOAP stands for is the first one goes same sign, which is positive, opposite sign, which is negative, and then always positive. For the negative one, right, same sign would be negative, opposite sign would be positive, and then again, always positive. Now, SOAP doesn't tell you about the, like, if it's a squared, ab, you kind of have to remember that. So you have to kind of, if this is a formula that you're interested in memorizing, you just have to memorize it. To be honest with you, for AP Calc, most of the time, this would come up is a calculator question, and we're going to kind of show you later how to use your calculator to factor this for you. So just kind of seeing the formula and being able to apply it for most of AP Calc will be enough. So anyways, on this guy, 8x cubed plus 27y cubed. As soon as I see the cubed, I'm kind of thinking, hey, that might be a sum of cubes. So I want to think, can I cube root 8x cubed? Well, the cube root of 8 is 2, and the cube root of x cubed is x. Can we cube root 27? Yeah, it's 3, and y cubed would be y. So now we're just plugging these in, right? 2x plus 3y. Then this next one is a squared. So we need to square the 2 and the x, so it becomes 4x squared. Then we're going to multiply them together. 2 times 3 is 6, and then xy. And we need to square the b term. So 3 squared is 9, y squared is y squared. Okay? Should be easy enough. Okay, if we see this one's even a little bit easier because it doesn't have all those coefficients. In this case, right, the a cube root of x cubed is x, and cube root of 64 is 4. And so then we just plug everything in. I'm not going to go through that for you. What I do want to talk about just very quickly is with those, you should really have memorized your cubes. So 1 cubed is 1, at least up to about 5. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64, and 5 cubed is 125. At least up to those are really the most common cubes. You should have those memorized, and vice versa. The cube root of 64 would go back to 4. Right, for all of these, it would just go backwards. So If you want to memorize past 5, that's awesome, but you should at least have up to 5 memorized. For squares, by the way, just while we're at it, you should really have memorized up through 12, maybe even 13. So I'll let you guys kind of do those on your own if you don't know them, right? But those are probably the most common that you should have memorized. 15 is actually good as well, so maybe even up to 15. I might throw one of those Mad Minute type quizzes with squares and cubes. And it's going to be too fast that you wouldn't have time to use your calculator. You just got to know them off the top of your head. So now, if none of these happen, so if we don't have a difference of squares, we don't have a sum of squares, we don't have a sum of cubes, or we don't have a difference of cubes, then basically, if you only have 2 terms, right, a binomial, you can't factor it. So if you just had something like x squared minus 7, right, that's not a difference of squares or cubes. So basically, we just can't factor it anymore. All right. Then the next one is if the problem instead is a trinomial, meaning it has 3 terms. The first thing you can watch out for, and really you can do this with the x method as well, but it's just the square of binomial. So if you notice that kind of the big key here is if you notice that, for example, in this one, if we notice that we have a 9, which can be square rooted, and then what is the square root of 9? It's 3. And then you notice this middle term is like double of 3. That's very common for just having the square of a binomial. But you definitely could do this, if you like the x method, you could have just done that with the x method. Again, I don't really remember which one goes on top, on bottom. So if I'm getting it wrong, you guys have to just forgive me and flip it yourselves. But we'd have 3 and 3, so that's why it was x plus 3 and x plus 3. Okay. A little bit harder would be something with an x and a y. And whenever you have an x and a y, what happens is, and again, I'll kind of use the x method, but what happens when we have an x and a y, and we see x squared, and then 1 of each, and then y squared, is just what's happening is that second term would have a y as well. So you can kind of not really worry about that too much. But in this case, if we look at that, again, you could do the x method. But if you notice, wait, hey, this is that sum of cubes. Well, what's the first one's square root? Would be 2x. And then what's the second one's square root, or the last one's square root, would be 5y. Right? So the square root of 4x squared is 2x. The square root of 25y squared is 5y. And the way you can check if this is actually a square root of cubes is multiply them together. So 2x times 5y is 10xy, and then multiply that by 2. Okay, and so we did get 20xy. Now it's negative, so it's going to be negative. So that's why it's 2x minus 5y and then squared. Again, if you don't like this method, you can just do the x method. Okay. So in all of these cases, if a is 1, then you can either just do your x method, or what I like to do is I like to essentially kind of do a little bit of a combination of what we call reverse FOIL and trial and error. So what I do is, if I was going to factor x squared plus 7x plus 12, this first one, okay, I like to just put x and then x, and it could be a plus, it could be a minus. And so then really what I'm doing is I'm just taking, 1 times 12 is 12. And I'm looking for what are 2 numbers that can multiply to 12 and add up to 7. Right? So I might try 6 and 2. Well, 6 plus 2 is 8. I might try 12 and 1. 12 plus 1 is 13. I might find that it was 3 and 4. So that's kind of what I'm saying by trial and error. Okay? We also might have one like this with a minus sign instead. And so it's the same thing, x and then x, right? But now, with the minus sign, what's going to happen is, when we're looking at that 12, instead of it being 2 numbers that add up to x, we could also be thinking what are 2 numbers that, add up to x but are both negative. So, or add up to 7, but are both negative, I said x. And that works too. So again, 3 and 4 add up to 7, but they're both negative. So x minus 3 and x minus 4, and that works. Now, both of these cases were positive, like positive 12 and positive 12. And when that occurs, both of your numbers will either be positive or both of your numbers will be negative. But essentially what you're thinking with these kind of the 3 and the 4 is those are going to be adding. When you get negative, so if I have negative 18, instead of adding my two terms, we're going to be subtracting. So with this one, I'm going to have x plus something, and again, x plus something or minus something. But with this case, we're going to be subtracting. So I want two numbers that would subtract to 3. So I don't write it in the x thing, but essentially it's the same kind of a deal. So two numbers that could subtract to 3 would be 6 minus 3. So this is x plus 6 and x minus 3. And again, with this one, it's the same thing, but now it's negative. So that one would be x minus 6 and x plus 3, because it's negative 6 plus 3 would give us to negative 3. So if that kind of made sense to you and you're like, oh, you know what, maybe I'll try it without actually writing in the x, great, I converted you. If not, just keep doing your x, I don't care. But here's the deal. If a is not 1, I really wanted to focus in on these, because if a is not 1, we really have to be careful. And there's a method that I like a lot, so I'm actually going to just kind of dedicate a whole nother page to it. And so that's factoring whenever a trinomial, when a is not equal to 1. Okay, and so sometimes we're going to get ones where, you know, we can actually you know, just do the greatest common factor. So we might have one like this where we have 4x squared plus 16x you know, plus 16. And what we can actually do here is we can actually, if we notice that there's a 4 in every single one, we don't have to do the x method. If we tried to do the x method here, it would be really hard. But instead, if we factored out a 4, this question is now actually really easy. And you just get x plus 2 and x plus 2, which simplifies to x plus 2 squared. So always check if a is not 1. Always first check if you can factor out a term like that. Because a lot of times you can, and then it makes your life a lot easier. But sometimes you can't. So sometimes we might get one that looks more like something like this. Negative 9x squared minus 6x plus 8. And so in this case, I can't factor out a term. Now, what I like to do is I like to do that same thing that I had, but instead of, before I put x here and x here, we're going to put that coefficient in front, negative 9x and negative 9x. And I know you guys can do it with the factoring, with the x method, but here's my issue with every single time you've done the x method. You guys will divide both of them by 9 or negative 9, and you'll totally get, kind of like a wrong answer. When you're trying to factor it, you'll have the correct roots, but the factoring part will be wrong. Okay. And actually, one thing I want to point out is actually this negative. So before we go any further, generally in math, they don't like to have negatives with your highest term. So something that, even though we might not think of this one as a greatest common factor, something that we want to actually do first is just factor out that negative sign. It's going to just flip everything inside. And this will actually be what the standard answers on an AP exam will look like, is they don't want to have that negative with your highest term. So just be careful anytime you see a negative in front. So this is going to be negative. And again, like I said, I'm going to put a 9x and I'm going to put a 9x. And if you want to kind of use the x method as well, you can. So again, I'm not sure if I'm doing it right, but 9 times 8 is 72. And then this is negative 6. So what I like to kind of think of is I need two numbers that'll multiply to 72. And then they're going to add or subtract to 6. Okay. And if you're not really sure, you can even break it down further. You can go like, hey, this would be 2 and 36. That might help me out. This is 6 and 6. And so now we can kind of use these three as kind of our starting point. You could even break it down to like 2 and 3. But, 2 times 6 is 12. So I have 12 and 6. Those multiply. And those would subtract to 6. But the issue here is, oh yeah, and this should have been a negative 72 because 9 times negative 8. So they subtract, right? So I have 9x plus 12, and then I have 9x minus 6. Okay, and so what I need to do though is, this is very, very important. If we FOILed this out right here, we would get 81x squared. We don't want 81x squared, we want 9x squared. So just like how here, right, we'd have like a 12 and a negative 6, how you'd have to divide both sides by 9 to get the roots. Well, we're not trying to get the roots, we're trying to get the factored. So we need to just divide out 9 once. We need to divide it to either side. So if both of these on the left could be divided by 9, we would just do the left side. If instead both of the right side could divide by 9, then we would just do the right side. But in this case, it's actually kind of a combination. Neither side can divide by 9, but this side could divide by 3, and the right side could divide by 3. If we kind of think, if we divide by 3 twice, that's the same as dividing by 9. So in doing that, essentially we did our process. So what's going to happen is this is going to be a negative 3x plus 4, and then 3x minus 2. And here's our final answer. Okay. Now, if you're not sure if that is the right answer, just FOIL it back out. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. 4 times 3x is 12x. And 4 times negative 2 is negative 8. So we get negative 9x squared plus 6x minus 8. And then if we distribute our negative, we get negative 9x squared minus 6x plus 8. And that was our original, right? Negative 9x squared minus 6x plus 8. So that's kind of how you might do something like that. Another one that we might see that's a little bit easier could be something like, say we have 3x squared. Give me 1 second. I had this written down and I lost it. Okay, so if we had something like 3x squared minus 10x minus 8. This one's a little bit easier. So in this case, same thing. I like to kind of put 3x and 3x, but just remember, anytime a is not 1, we're going to have to divide by 3. Okay, so sometimes I'll even circle it when a is not 1, just so I can make sure, hey, I need to divide that out. And you could check, do I have any common terms? No, we don't. So now you do whatever you want to do here, but basically I need two numbers that are going to multiply to 24, or really to negative 24, and then subtract to 10. So 8 and 3 don't work, but 6 and 4, technically they could add to 10, but because it needs to go negative 24, this negative means one number needs to be positive, one needs to be negative. So 6 and 4 actually don't work. But 12 and 2 work, because 12 minus 2 is 10. But we need the 10 to be negative, so we're going to have 3x minus 12 and 3x plus 2. Again, if you wanted to have those up here, that's fine. But what I want you to be careful about when we're factoring is, a lot of you guys will do this. I see you do that. And that works to get the roots, the answers, but it doesn't work to get it perfectly in factored form unless you really know what you're doing. So what I like to do is just here, divide by 3 on the left side, right? We couldn't divide on the right side, but it's okay. We only want to divide it once. The last time, the reason why we were dividing both times is because we couldn't get to 9, right? Neither one divided by 9, but we're like, hey, wait, we could do dividing by 3 on both sides, and 3 times 3 is 9. So here, we can actually just straight divide out the a. The a was 3. That's what we want to divide by. So this is x minus 4 and 3x plus 2. And so that's our answer. Again, I'm not going to show this because this video is already way too long. But if you wanted to FOIL it out, you would get that answer back. Okay. Next up, we have our 4 terms, right? So that was with 3 terms. And so next up, we have 4 terms. So the most common thing with 4 terms is the grouping method. Okay, and the grouping method is you basically look at your first 2 terms and kind of group those. And then you look at our second 2 terms, and be careful, the negative counts. So the negative counts as part of those second 2 terms. And then kind of try to isolate those together. So from 5a and minus 5b, what could we factor out? We could factor out a 5. So I'm going to kind of jump over here and show it. So we're going to factor out a 5, and we're left with a minus b. So that's from this first term. Okay, and the negative xa and the negative xb, what could we factor out? We could factor out a negative x. You want to factor out the negative with it, because remember, we want to flip it to make it x become positive. So we're going to factor out a negative x. When we factor out a negative x from this, we think negative xa divided by negative x would be positive a, and positive xb divided by negative x would be minus b. And so now what we can see is in both of these, what's the same? Well, in both of these, they have an a minus b term. So what we're doing is we're actually factoring out this a minus b term, and what's left over is 5 minus x. So there's our answer. Okay? I think most of us are pretty good at this one. So I'm not even going to worry about going through the example. You guys can look at it on your own. But essentially, you know, we're grouping these 2. We can factor out an x squared. We're grouping these 2. We can factor out a 2. And we'll get to our answer. Now, if you're not going to worry about the super bonus worksheet, then just stop here. Don't confuse yourself. Just, go ahead and get started on the regular worksheet. The regular worksheet, you are going to do just the odds. You don't need to worry about the evens. They're not going to be a bonus because I have that super bonus worksheet instead. So only do the odds, okay? I think there was one question that I wanted you to do besides the odds. Let's look at it right now. It'll be posted. So, yeah, so we're only going to worry about the odds and number 26. Okay? So, actually, I'll be mean. We'll do 24 also. So, we're only going to worry about the odds and then 24 and 26. The top is just factoring. Just kind of think of those rules that we just did. Right? First, GCF. Second, think, is it 2 terms, 3 terms, or 4 terms? And if it's 2 terms, we're thinking squares or cubes. 3 terms, we're thinking X method. Just be careful about if A is not 1. And 4 terms, we're thinking grouping. Okay. Then down here, solving. I didn't really do any examples on solving, but it's just, I kind of showed it at the beginning. It's just that last step. Is once we have something like, say we had x plus 3 and x minus 2 equal to 0, then we'll just get x equals negative 3 and 2. So we're just kind of doing that last step of finding the roots. And then the bottom ones, again, I didn't show an example of this, but I think we can figure it out, is we're going to simplify each one of these. And so we have to factor out the top and the bottom. So since we're not doing the evens, I'll do one of the evens as our example. I'll do number 32 because it's a little bit trickier. So we have 50x plus 70. What could we factor out of the top? We can factor out, really in this case, I think just a 10. So if we factor it out a 10, we'd be left with 5x plus 7. Now in the denominator, before you do x method, let's first factor out. What can we factor out of the, what common term can we factor out? We can factor out a 10. So if we factor out a 10, we're left with 3x squared plus 8x plus 4. And this one's a little bit meaner because of the a is not 1. Okay, so I'm going to do this off on the side. So we know that's going to be 3x plus something and 3x plus something. The reason I know they're both plus, by the way, is everything was positive, so we can't have any subtracted. So 3 times 4 gives us 12. Okay. So we're going to kind of have 12, what 2 numbers multiply to 12 and add up to 8. Well, 6 and 2 do that. So it's 3x plus 6 and 3x plus 2. But remember, because of that 3, we need to divide one side by 3, and in this case, that's the side that can go. So this will become x plus 2 and 3x plus 2. And if you're not sure about your answer, just FOIL it out, and you should get back to 3x squared plus 8x plus 4. So now I'm going to kind of do that. 10 times 5x plus 7, all divided by 10 times x plus 2 and 3x plus 2. Now, in a lot of these other ones, we're going to have things that cancel out. But in this case, only the 10s cancel out. So this would be our answer. So in this case, there are not any exclusions, right? One of the question says to simplify each and then state any excluded values. Well, in this case, there would be no excluded values because we didn't cancel out any x's from wholes, but there are excluded values from the denominator. So remember, one of the rules is the denominator can never be 0. So our excluded values would be x cannot equal to -2 or to -2/3. And the way I got those was I just set the denominators equal to 0. On the answer key, you'll see they kind of write the excluded values like that. I like to write them. I would like to write this as like x is not equal to -6 or -2, so that's how I can see it on your homework. But just be careful. Here I didn't like cross out anything with an x in it, but if you do, that's also going to be excluded. So like on number 28, 28 is really easy. We're going to zoom in and look at that. The top factors to x minus 3 and x plus 1. In the bottom, we can just factor out a 3 and we get x minus 3. So even though we factor that out and our answer will be x plus 1 over 3, that's our answer. But there still is an exclusion of x cannot be 3 because it's going to be a whole. When you cancel something out, it becomes a whole. So just be careful. Basically, the way we're getting these excluded values are both the denominator can't be 0, and then anytime that we like have a whole or something that cancels out from the top and the bottom, we're going to set that to not be 0 either. Okay? So if you're not going to worry about the super bonus homework, then stop this video. You're done. It's already pretty long. If you want to try the super bonus video, they're just kind of 2 little bit harder cases that we have. So with 4 terms, we're going back to those 4-term cases. If you see the grouping, that's what you want to try first. It's the easiest. But if you can't group, then we're going to combine the first 3 terms together. So if we look at this example, x squared plus 6x plus 9 minus y squared. If I tried to group, and we could have tried this with grouping, right? If I tried to group, we would notice that in the first one, yeah, I could take out an x, so I get x plus 6. But in the second one, I can't take anything out. And so I only have 9 minus y squared. So this doesn't work with grouping. With grouping, right, there had to be a repeat. Like up here, see there was an x plus minus 3 and an x minus 3. Here we don't have any of those repeats. So grouping didn't work. So if grouping doesn't work, we can either try to group the first 3 terms together, the last 3 terms together. You may have to reorganize it. But basically we're trying to group 3 terms together. B and C are kind of the same thing. You'll notice this says the first 3 and this one says the last 3. So basically what we're looking for is hey, wait, is there anything that actually would have an x method? And so if we look at x squared plus 6x plus 9, we can do x method with that. And what's going to happen is when we do x method, we actually get the 3 in the 3 case, right? So it becomes x plus 3 squared. And now that we have x plus 3 squared and then minus y squared, this actually goes back up to this binomial problem. And it's a difference of squares. So that's where I was kind of showing you this, right? And saying we're going to see something advanced with that later. So when we see something like this, right, we would have the x plus 3 is like our a term, right? And the y is like our b term. So we get x plus 3 plus y, and then x plus 3 minus y. And you can just kind of drop the parentheses and get to that final answer. Okay. I know it's a little bit funky, but it kind of is what it is there. If you look at C is very similar, but it's just with the last three terms. And also notice that we actually factored out this negative. So we put minus, and then we changed all the terms because the plus became minus, the minus became plus, because what we did is we factored out that negative. So we grouped the last three terms together, and when you factor these, it's -3 and -3. So you get y squared minus x minus 3 squared. So kind of our A term is y plus 3, and our B term is the x minus 3, and you can kind of go from there. So what I'll kind of show is, hey, we had foiled this one out. So we know what the final answer should be when we factor it. This should be our final answer. So we foiled that out. Let's see how we would look at something like this, which actually isn't kind of looking the right way. How could we get this to get factored? So we said we want to look at, would the first three terms work? And I know this is scary because of the y, but let's just kind of roll with it. Can I square root this, and can I square root this? Yes. So my A term would be 4x, and my B term would be y. So this becomes 4x, right? We're going to group this together. 4x plus y squared minus 4. And so now that can become 4x plus y. And so again, we could square root here, we could square root here. So 4x plus y plus 2, and then 4x plus y minus 2. And so that becomes 4x plus y plus 2, and 4x plus y minus 2. I'm kind of looking back up here, right? That's what we had. So I know that it's a little bit weird, but like I said, if you're gonna try this bonus worksheet, then you're gonna have to kind of deal with that. So what the bonus worksheet is gonna look like is it's gonna look like this. So we have 40 practice problems, okay, and then we have the answers. And like I said, this is kind of like super bonus. So these are very hard. I do want you to show work. But because it's a lot, what I'm going to allow us to do is you can either choose the evens or the odds. You don't have to do all 40. I don't want you to do 1 through 20 because the ones at the end are good. So you can choose to do the evens or to do the odds. And what I'm going to do is, if you do this super bonus one, I'm going to just give you 1,000 out of 0 because they're going to take a while. So that's like having like, hey, I totally missed a homework, or I just bombed a homework, and this will kind of take care of that for you. So I'm giving you guys a lot of extra credit opportunities now at the beginning, just because this review is so important, just to kind of get you out ahead. So let me know if you guys have any questions with this. I'll be around on email. Hopefully we'll have office hours tomorrow. I don't know exactly what the school is planning. I just know that they had some issues in a couple classes, so they wanted to just pause everything today and figure out what their policies were going to be with that. So anyways, good luck with this, and I will see you guys in class soon.